So as we're looking at today's lesson, we're looking at similar figures and scale factor. So the question becomes, how do I use scale factor and similar figures to find missing measures? Your learning intention. I'm learning to identify similar figures and find their scale factor. So find the coordinates of the triangle after being transformed by the indicated scale around the origin. So if we're looking at a scale of 1/3, what do? Pause the video and complete the warm-up question now. Well, I do hope you tried. So if we're looking at a scale factor of 1/3, E is the 0.63. F is the 0.69. And G is the -6.9. So what do we do with the scale factor? We multiply. 6 times 1/3, that's the same as 6 divided by 3, gives me 2. 3, 1/3 of 3. 3 divided by 3 is 1. So that becomes the 0.21. 6 divided times 1/3, 6 divided by 3 is 2. 9 times 1/3, 9 divided by 3 is 3. -6 times 1/3 is -2. 1/3 of 6 is -2. 9 times 1/3 is 3. So this is 2, 1. This is your E prime. And 2, 3 would be your F prime. And -2, 3 would be your G prime. Connect your dots. And you now have transformed it by a scale factor of 1/3. Okay, we were able to do the scale factor of 1/3, but are we going to be able to draw the figure after a scale factor of 2? No, because it will completely go off of our grid. So if I am looking at 6, 3, 6 times 2 is 12. 3 times 2 is 6. 6, 9. 6 times 2 is 12. 9 times 2 is 18. -6, 9. -6 times 2 is -12. 9 times 2 is 18. Those are your new coordinates. Even though we cannot graph them, we know that that is correct because we multiplied both the x and the y by 2. So now we're going to look at similarity transformations. Corresponding angles of similar figures are what? If you stated congruent, remember this is our symbol for congruent, you would be correct. Corresponding sides of similar figures are what? They're not congruent. They are proportional. That should be PRO, not POR to begin with. Proportional. That means that they are in the same ratio. And that brings us down to what is the ratio of the length of the two sides? That is your scale factor. In other words, you've got the length of your first side multiplied by your scale factor, and you get that second length. The scale factor is the ratio of the length of the two corresponding sides. The number you multiply by to get the transformed length. Okay, now, determine whether quadrilateral ABC is similar to LMNP. Okay, so how will we do that? Well, let's look at the corresponding sides. If I'm looking at side AB, it is 2. LM is 1, 2, 3, 4. Okay, let's look at BC. BC is 2. Let's look at MN. 1, 2, 3, 4. What do you notice? Well, if you multiply the first length by 2, you get the second length. Okay, let's look at DC. And that is 1, 2, 3. Let's look at PN. We're thinking it should be 6. 1, 2, 3, 4, 5, 6, and we are correct. What about the one that is at a diagonal? AD and LP. Well, I can look at it. I go up 2 and over 1. I go up 1, 2, 3, 4 and over 2. So that tells me that they're in the same slope. Theoretically, if you think logically, they should be the same. But we can use the distance formula. The square root of this is my x here is 1 and 2. 1 squared plus 2 squared. And this time we're going to get an approximation. That's approximately 2.24. Okay, what about PL or LP? Square root of. This will be 4 squared. There. Okay, let's back up a little bit because I did this one incorrectly. Okay, so the difference, so if you're looking at the difference of x, that would be 1 minus 2, and that would be negative 1 squared. Okay, if you're looking at the difference of y's, that's negative 1 to positive 1. So that would be 2 squared. So I do have it correct. So for this one, we're looking at, it goes from negative 1 to 3. That's the difference of 4. For my x, it goes from 4 to 6. That would be 2 squared. And you get 4.47. So as you can see, they're approximately multiplied by 2. So it is, they are similar. And the scale factor is 2. So they're similar because I can take the length of one side, multiply it by 2, and get the length of the other. This is off because of rounding. If we did not do the rounding, we would have been right on the money. If you have any questions, back it up and look at the video again. Explain how the coordinates of L, M, N, P and L prime, M prime, N prime shows that a translation maps LMNP onto LMNP prime. Okay, so let's look at it. L is the point 6, 3. M is the point 10, 3. N is the point 10, -1. And P is the point 4, -1. Now let's look at their transformed images. L prime is 4, 2. M prime is 7, 2. N prime is 7, -2. And P prime is 4, is 2, -2. So what will do the mapping? Well, we notice that it isn't all, because we've got odd numbers and stuff, it looks really strange. But if you notice, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, we can look at it. This is subtracting 5. Okay, so if I start here, for my X, I subtract 2. For my Y, I subtract 5. And that is my vector that I use to move this quadrilateral to the other spot. Okay, so as you're looking at this, all you have to do is subtract 2. We might be off on our M and N. That should be 8. Now, 6 minus 2 is 4, 10 minus 2 is 8, same again, 4 minus 2 is 4, or 4 minus 2 is 2. Here I subtract 5. I should be subtracting how much? How many am I going down? I'm going down 1. I should subtract 1 and I'll get that new. So 3 minus 1, 3 minus 1, negative 1 minus 1, negative 1 minus 1. So my vector is negative 2, negative 1. So how do I transform LMNP onto ABCD? There's two things that happen. Number one, is it the same size? No. This is 4 and this is 2. So it is 1/2 as big. But the first thing we've done is to move it to the left and down. So for my vector, I go over 1, 2, 3, 4. So it's negative 4. And then I go down 1, 2, negative 2. That's your translation. Then multiply. Then the scale factor, I'll just say scale factor because that's what I should be using. Then the scale factor is 1/2 because the picture is 1/2 as big. Okay, so when we've got similar figures, so as we're looking at our scale factor and all of this, we want to know which side of the image is parallel to LN. If we're looking at LN, this is LN, and it's over, the L is at 1, 3, the M is at, oh, this is LN, N is at 4, 1. So it would be this side, which would be PR. Okay, which angle is congruent to angle L? Angle L and angle P. How would we show that? Well, we would look at using one of the sine, cosine, or trig functions. Okay, is triangle LMN congruent to triangle PQR? It is not congruent because the length of MN is equal to 2. The corresponding side would be QR is equal to 4. Is it similar? So congruent means the same shape. But would it be similar? If I'm looking at this, this is 2, This is 4. That's multiplied by 2. This goes over 1 and up 2. This goes over 2 and up 4. That would be the same length. This one, from R, you go over 1, 2, 3, 4, 5, 6. And you go up 1, 2, 3, 4, 5, 6. And this is over 3 and up 3. So as you can see, they are in the same proportion. And we can state that triangle LMN is similar to triangle PQR. Okay, what scale factor transforms it onto PRQ? Well, it's going from 2, let's see, we're going from the smaller one to the bigger one. So your scale factor would be 2. Okay, how do we translate it? If I look at L, I go right 1, 2. So this would be plus 2. And then I go up 1, 2, 3. And that is my vector. Okay, so if we are looking at quadrilateral ABCD being similar to quadrilateral PQRS, then we can set up our corresponding sides in the same ratio. We can set up those ratios. So this is side BC, and this is what we're looking for. BC is the middle. QR is the middle. Those correspond. 6.25 over 10 is equal to X over CD is the last 2. RS is the last 2. RS is 8. So now we take 8 times 6.25 and then we divide it by 10. Eight times 6.25 divided by 10, and we end up with 5. That would be 5 centimeters is equal to X. So you can see how you have to set those proportions up. You use your corresponding pieces to set up your proportions, and then you solve. You know you're successful when you can identify similar figures and find their scale factors. So we are looking at similar figures. Scale factor. And setting up your proportions. Setting up ratios. That's to find measures.